Greetings. We're going to in this clip take a look at the queuing analysis of something like Neighbors with um, online orders assumed, meaning zero order processing time. So the analysis that is then just the beverage prep to see how that impacts things like customer waiting time, barista utilization. So you've got measures of the CX and the EX. So this is where the Google sheet lives, excuse me. We have opened it here. This initial table features information from tables 2 and 3 in the case. So you can see I've got all the coffee products here, along with information from those tables. This is the fraction that you're working with. So you're going to change numbers in this yellow column, and down here as well for the rate. I believe those are the primary sort of controls of the spreadsheet. You've got the labor mean, labor standard deviation, non-labor mean, non-labor standard deviation, and then there's some protected columns back here for calculations that you don't have to worry about. So we've got down here, essentially what we're doing is we're converting the entire Neighbors coffee shop to a single server, a single queue, possibly with multiple baristas, multiple servers, but it's just one queue. And so I'm thinking GGK here, the GGK model, and we're going to compare our spreadsheet results with the GGK model just as a verification step. In the current setup, you can see I've got all of the fractions set to 0 with the exception of the seasonal latte. You do want to make sure that your total here is 100%. Otherwise, of course, invalid, that your analysis would be invalid. We're also going to look at the base case of arrivals at the rate of 40 per hour. Now, this cell here is calculated from all this information here. So if I change out the fractions, which we'll do, in the latter part of this clip, I guess we'll do a 50% drip, 50% espresso, and you could come up with your own design as part of Neighbors 1. But that reflects here in a revised or a calculated mu, the service rate of sort of a proxy customer, because we've got a bunch of different products. So we're calculating a proxy of sort of a weighted average based on those fractions, the probabilities that a customer orders one of these products. So you've got the labor C sub V, CV sub P squared. You've also got a non-labor mu and a non-labor CV sub P squared. All right, so the GGK calculation essentially is also requires you to specify how many baristas you've got. So we're going to go with 6 in the base case. You should vary this along with lambda and along with, you're going to look at the base case. So you'd have to go back into table 2 and 3, I guess, pick up those default probabilities, plug them into your table, analyze that setup for lambda equal to 40 and other lambda values that you decide are going to be appropriate. Because you want to give, some sort of tabular guidance to the owners, if they were to franchise this concept, perhaps communicate it to others, trying to, sort of like surface the importance of staying away from high utilization to protect the baristas and, of course, the customers. Where they're pooling the orders is a smart move, psychological elements, and then the impact of variance. Should Spencer and Lulu aim for a substantial reduction in the variance somehow through training and automation? Okay, so this is our basic setup. You've got the labor components, you've got the non-labor components, and we're coming up with an estimate here. So the non-labor component is very rudimentary. I'm not using a queuing model for that, but I am using the GGK model here. So we're going to verify this 5.187 minutes. So the total flow time from the time of placing the order, the order is already received rather, because here we're assuming it's online ordering, but from the time that the barista basically receives the order to beverage in hand is going to be 5.604 minutes. So this begs the question, just for my taste, I think this might look reasonable to some, but I wonder if I'm overspending here. So I might consider going to 5 just to see how that is going to change my flow time. It's 5.9. That's saving an annual salary or annual compensation of one barista. That makes a material difference without seriously impacting the experience. 5.6 to 5.9. We'll go to 4. Now it's starting to bounce up, and I'm not clear I'm going to be able to get it done. See, 3 is not going to do it. If it goes negative, that just signals that lambda is above mu. You can see here I've got a lambda of 4, so if I had 3 servers, that would be a production rate of 36, so that's not going to be enough. You'd need to go to at least 4. And also, if I go to 10, it's not really impacting you, just spending money on labor, but you're not getting much windfall for it. So I'm going to go back to 6 and just leave it there. This is something that you need to decide. Staffing, for different, the purpose of the cheat sheet is to provide guidance to the owners for what staffing should look like at different for different menus and for different arrival intensities. Okay, so let's just verify this setup here in the GGK calculator. This is available in the simulation, in the queuing module. I have an arrival rate of 40, a service rate of 12. That's directly from the table. So even if you do choose to verify everything manually, you would presumably just have some sort of calculator to calculate the mu and CV sub p squared values from the table 2 and 3 data. All right, so for a Poisson process, which we're assuming here, CV sub a squared is 1. The CV sub p squared is 0.011. Just verify that down here. And I'm looking for 5.187 minutes. I've got 6 baristas. I go ahead and submit. And you can see I've got a W sub S, which is the time in the system of 0.0865. Multiply that by 16, you're going to get your 5.19 minutes. Right. So no need to use the independent calculator unless you really feel some verification is needed, or you just prefer to work sort of like from first principles almost. Sort of as an alternative to having a pure seasonal latte shop, I'm going to take that all away and make this 50%. 50% drip, 50% espresso. Surprising number of people actually prefer drip coffee. Just verifying my total here. And you can see I've got a change now in the labor because I've moved from all seasonal lattes, which are one of the heaviest labor component drinks in the list. I'm now 50% latte and 50% drip. So that's a lower labor content beverage, the drip. So now my rate has gone up to 60. And my CV sub p squared is now larger, 0.072 instead of 0.011. And what's the consequences of this? I'm now down to 1.29 minutes, 292 minutes. So you can see that I need to have at least, so mu is 60, so it actually exceeds it. Maybe could do it with 1, but that's going to blow my time up. But if you had a shop like this and you just ran it with 1 barista, see you're doing 2.3 minutes turnaround, and the employee is busy 2/3 of the time, so presumably that would be workable. If you go to 2 baristas here, it probably is going to sort of like create a sense of excessive idleness in the baristas because they're only working 1/3 of the day. There are perils sort of on both sides of the utilization coin. Go too high, you're burning out. If you go too low, you have folks fearing for their job, feeling sort of unoccupied, and that maybe they would rather take a higher wage and just have 1 person there to service the drinks. So I'll leave that for you to decide, but let's just verify this once. So we're at, if I've got 2 baristas, I'm at 1.369 minutes. So let's just verify this. Just make sure that all works. So this is 0072, and I'm doing one or two, I guess, right? Yeah. Let me submit. And I'm interested in the 0179. Plug that in. 0179 and 60. That comes back at 1.074 minutes. 1.077, close enough. Okay, and then you add in the non-labor, 1.369. Works for me. Okay, in the next clip, we're going to look at the AnyLogic model where we're going to add the ordering stage back in. And there you could decide if you want online ordering to be a thing, sort of QR code based or maybe website based. And if so, you know how that impacts your CX and EX and your design. There, we're going to expand our staff roles.